So, if 2 cubed means 2 times 2 times 2, what is it equal to?
8.
8.
Or just write the number.
If 2 squared is 2 times 2, this is equal to
4.
4. If 2 to the 1 is just 1, 2, then it's just equal to 2. And now I want you to find a pattern. Because check this out. From 8 to 4, we divided by
4. I mean 2.
2.
2.
And then we divided by
2.
2. And if we do that again,
It's going to be 0.
no,
Oh,
what's
wait.
2 divided by 2?
1.
1. And you guys brilliantly just figured out the zero exponent rule. 2 to the 0 is equal to 1. And if you divide it by 2 again, what happens when you take 1 and you divide it by 2? You get 1 over 2, which is 1/2. Okay? Next one. 3 times 3 times 3 times 3. Ooh.
8.
Brody, where are you going? Oh. Now, that's, hey, Brody. Brody.
You're losing me. Bro, you lose. Bro, like, all of you and Jaden, you try to be like very smart. You can't. You just need to play.
Hey, anybody know what that's equal to?
27.
27. And 3 times 3 is 9. So what did we divide by? 3. And then you divide it by 3 again. Any guesses what 3 to the 0 is?
3 over
It's
0.
1. You divide it by 3 again. What about 3 to the negative 1? 1 over 3. So this is your zero exponent rule, that anything to the 0 is equal to 1. Okay? And we learned the negative exponent rule last time. Negative exponent rule says if I had 5 to the negative 3, this I can switch to the other side of the fraction and make the exponent positive. If I had 2 to the negative 3 over 5 to the negative 2, this would go positive at the bottom and this would go positive at the top. It switches to the other side of the fraction. That's your negative exponent rule. And part of the reason the zero exponent rule works is with this question. The shortcut says if you divide and the bases are the same, you should subtract. And if I subtract, what do I get if I get 3 minus 3? I get 0, and anything to the 0 is equal to 1. Or, I could have figured this out as a number. What's 2 cubed? 8. What's 8 divided by 8? 1. So kind of neat that they're the same answer, whether we use our new dividing shortcut where we subtract the exponents, or we just evaluate it. And math should work this way. So if I actually figure out these numbers, it's going to be 8 divided by 8, which is 1. But if I use the shortcut that says when you're dividing powers with the same base, you can subtract the exponents, and 3 minus 3 would be 0. Then I would get 2 to the 0. And our zero exponent law also says that it should equal 1. So that's what it's in the box for you there. The exponent of 0 law. Anything to the exponent of 0 is equal to 1. And it doesn't matter what the base is. You can add the word the. I forgot it in your notes.
What?
I forgot the word the in your notes. So you can add it in. The only thing that's not allowed is you're not allowed to do 0 to the 0. If you try that on your calculator gets mad at you in the best way that it can and just says error or syntax or not possible. Something, it doesn't yell at you, doesn't scream. But if you do 0 to the 0, it's like, no, that's not an answer. You can try it. See what your calculator does. So let's do some work. What do you think 5 to the 0 is?
1.
1. What do you think 325 to the 0 is?
1.
1. Oh, you guys are good. This next one's tricky. What do you think the next one is?
Negative 1.
It's negative 1. Because first order of operations, you would do the 2 to the 0. The 2 to the 0 is 1, but there's still a negative out front. So this one is negative 1. That one I could probably have caught you on the quiz with. If I gave you that one, would you maybe just put 1?
No.
But what about this one? Now it's in brackets.
Negative 1.
That one's going to be positive 1.
Positive 1?
Because if the whole thing is to the 0, doesn't matter what number's inside. Doesn't even matter if you don't even know the number. It's going to be 1. What do you think the next one is?
1.
Close.
2.
This one is 1. This one is 1.
2.
Take out your calculators.
It's
And
better.
2. Four times 3 to the 0. Order of operations say we do the exponent first. So what is 3 to the 0? 1. And what's 4 times 1?
4.
Order of operations say you do brackets first. So I'd have 2 plus 3 is 5, minus 5 is 0, plus 4 is 4. And then I'd have 4 to the 0, which is
1.
1. This one says do brackets first, so I'm going to do the brackets first. 2 plus 3 is 5, minus still 4, and I have 0. And then order of operations say do the exponent next. What's 4 to the 0?
1.
So this will be 3 times 1, and what's 3 times 1?
3.
Well, I got the answer down there too. It's 3. You like the 0 exponent rule? Next, we have the power law. Part 1, a power. 2, a power. So you already know in expanded form that 2 cubed means 2 times 2 times 2. And if you had that 3 times, you would write that as 2 cubed. No problem. But now, what happens if we have a power and then another power? There's a shortcut for this, but to begin with, the 4 means that I'm going to have something 4 times. What am I going to have 4 times? I'm going to have
2.
the 2 squared, which is 2 times 2, 4 times. How many 2's is that altogether?
4. I mean, oh no.
Ooh,
8.
8 of them. Okay, so you hit the green button, and then no, the other side. No, get it into the map. You might want to redo some of these non-fractional terms. And now that one. There's a shortcut, x squared cubed. Well, the cubed would mean I have x squared 3 times. And x squared means x times x times x,
I don't know the
x times x. How many x's do we have?
6.
We have 6 of them. Can't see that? Did you say you can't see it? Yeah.
Yeah, I can see that.
Do you need glasses?
No,
No?
yeah.
Yes?
No, I don't need glasses.
Do you want to sit closer?
I'm okay.
Okay. Do you see a shortcut? Do you see a shortcut? Because I do not want to, I don't want to write this one out 9 times, 5
2
times.
times 3.
There's a shortcut.
Can you just do the 2 that's
This is going to be 7 to the something. If you see the shortcut. If you don't see the shortcut, I'm going to get you to write out 7 to the 9 5 times. And then every 7 to the 9, I'm going to get you to write 7 times 7 times 7 times 7 times 7 times 7. That many times.
7 to the power of 63. Wait, what?
There's the shortcut. How does the shortcut work?
Oh man, it's
You add like 9 and the 5. I mean, no,
9 times 5.
multiply.
We multiply the 9 and the 5. Or you could add the 9 and the 5 and make a really big mistake and maybe you get it right.
Answer.
Yeah.
¿Puedo dar un ejemplo como hacer todo más rápido?
One more example. See if we can get it really quick. Let's see. I'm going to do 3 to the 11 to the 5.
55.
55.
3 to the...
Power of 55.
Yes. Very nice. So the shortcut rule says if you have a power to a power, you can just multiply the powers together. So we can highlight this here. When a power is raised to another power, you can multiply the exponents. Again, whenever you forget, you can just write the expanded form. An exponent means repeated multiplication. If you forget a shortcut, you can write the repeated multiplication. So let's see if we can get some of these. What do you think this one's going to be? Oh, that's the old one.
20.
It's going to be
Power.
5 to the
20.
exponent of 20. Ooh. 2 to the negative 3 will equal 2 to the exponent,
Negative. Oh, 6.
negative 6. Or you could write this one on the bottom with a positive 6.
Wait, write that in my calculator. Come as a decimal.
Wait,
Can you write it in your calculator as that?
You can write in your calculator, and it doesn't add them, it doesn't do the shortcut, it always get the answer. But in your calculator, hit the math button and push enter on number 1 fraction.
What page is it?
Push enter again, changes it back to a fraction.
If this be like a minus exponent, would it be in a fraction?
Like whenever you have a minus exponent, it switches to the other side of the fraction. So this is technically in your numerator because I can make it over 1. So then it goes to the denominator to make it positive. And the last one. What is minus 4 times minus
Uno.
5?
20.
20.
Uno.
Positive 20.
Pero no es negativo.
No, porque negativo por negativo es positivo. Okay.
Are you going to give us a worksheet now?
I'm going to give you a worksheet, don't worry. The second part of the power law.
14. I mean, no, yeah.
If you have a product inside of a power, each base gets the power. And again, I think this is easiest to see, okay? A couple of ways we could do this one. First of all, you could think of it like this. The cube means repeated multiplication. Okay? So if I think of it this way, do you see that you have a 4 3 times? And you have a 3 3 times. So you could think of it like that. You could also switch colors here, or you could have done the brackets first. What's 4 times 3? And you could get 12 cubed. So different ways of looking at it gives you the same answer. I think I like the 12 cubed, it looks simpler. But you could write this one either way. And it says evaluate. Evaluate means take out your calculator. I don't know, I'm hoping that's right. Can someone check on their calculator?
What? No, it's not.
12 cubed? Is it 1296?
17.
Oh, it's more?
Yeah.
Okay.
It was. Let me see.
What's 12 cubed?
4,
12 times 12 times 12.
12 times 12 times 12.
Mm-hmm.
1728.
1728, thank you. And in part B, we could do this as 2 times negative 3 is negative 6 to the 4. And we could type that into our calculator. And this, I think, is the 1296. Maybe I got this one right. You type that in exactly that way, is that correct?
Wait, I did it wrong.
You'll need brackets, and you'll need to, on that
Oh, yeah, I
calculator,
did it wrong.
you have to use the negative sign. So go bracket.
Bracket.
This is your negative.
Yeah.
Power of 4. Yes, I got that one right. Good. Or I could think of this 2 and negative 3, 2 and negative 3, 2 and negative 3, and 2 and negative 3 4 times, which means I would have the 2 4 times and the negative 3 4 times. And this will be 16 times 81, and it also equals 1,296. I think I like the green way better for these ones.
Green.
So for this one, I would probably do that first. And what's negative 12 times negative 12? Does anyone know 12 times 12?
100.
144. Excellent. But as soon as we have variables in there, like these ones, I actually like it right now. We're going to write it out. 3x squared is going to have to happen 3 times. Right? Because that's what that little 3 means. And if you multiplied that all together, how many 3's would you have? 1, 2, 3. 3 cubed. How many x's would you have?
2.
You have 2 here, and another 2 here, and another 2 here. In total, you would have
8 or
6 of them. And 3 times 3 times 3, you could actually write this as 27 x to the 6. I'll do the next one in blue. If it's squared, that means you have this twice. That's what squaring means.
But it takes up so much space.
4 times 4 is
16.
16. How many a's are you going to have? You have 4 here, you have 4 there, and they're all multiplied together. The first one. So I took the cubed here. Highlight that in yellow. I took this 3. Oh, that's not yellow. That's interesting. I want it yellow. There we go. I took that 3 and wrote it 1, 2, 3 times. Okay? And then I looked and I said, if I'm multiplying that all out, do you see that you have 3 times 3 times 3? So I have 3 cubed. 3 times.
But why is that?
Well, I have 2 x's here, and another 2 x's here. Now I have 4 x's, and another 2 x's here. Now I have 6 x's. 6 x's all together, put together. If you have 4 a's here, and 4 a's there,
And how is it?
how many a's are we going to have in total? 8. And if I have 3 b's here and 3 b's here, 6 b's in total.
Wait, how is it 3 to the power? The first one.
How do I get 3 cubed?
Yeah,
Because 3 times a 3
yeah.
times another 3 is 3 times 3 times 3, which is 3 cubed, which is 27. Because I have those 3 3's all together, and repeated multiplication is an exponent. The last one in green. If I have a cubed, I would have this, oh my goodness, 3 times. If you put the numbers together, -5 times -5 times -5,
Answer, yo quiero decir la respuesta.
-125. I can explain the second one for you again. Let me just finish this third one, and then we can go over the second one and the third one again. So now we have to think, how many x's are there? This is x, 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 x. All together,
6.
60. How many y's do you have? Y, y, y? 3 of them. How many z's do you have? Z, z, z? Z, z, z? Z, z, z?
It's 9.
9.
So what is the square root of?
Okay, you want the second one explained again? So this squared, take my yellow pen out, means I write it twice.
Okay.
Okay? And now we're multiplying, and so I put the big numbers together. What's 4 times 4? 16. That's why there's a 16 out front. Then I put the letters together. How many A's do I have? I have 4 here and another 4 there.
8.
8 together, all multiplied together, so I can write A to the 8. How is it A to the 8? I could take one extra step, let me write it out. I usually just imagine this step in my head,
So we add those.
right? I have, and then I'm multiplying here for A, B, B, B. If I rearrange these and put the numbers first, and then I put the A's,
Would you accept k to the -4 exponent?
oh, instead of K, 1 over K to the 4? Yeah, that's fine.
Even though
And
it
then-
says should contain a root of.
So how many A's are there? There's 8 of them. Okay, do you see why we don't always want to write it down?
Yeah.
Because it gets a little annoying to write so many things down.
Está muy fácil, ¿verdad, Daniel?
Okay. So we will leave part 3 for Monday.